Okay, so here we are at the last video for electrochemistry, and really the last video for my class of AP Chemistry. And so we are going to wind up here talking about electrolysis. And electrolysis is going to be really exciting to all of us because not only are we going to be talking about redox, but we are going to be using stoichiometry in some of the calculations, right? And I'm sure you're all thrilled to hear this news and can't wait to get to calculations, but you're going to have to wait just a second so that we can define what electrolysis is. And so electrolysis, or an electrolytic reaction or electrolytic cell, is something that uses an external voltage source like a battery to drive a redox reaction that is not spontaneous. And this process can be used for several things, including the separation of metals from molten salts and electroplating of one metal onto another, which is always good. And where stoichiometry fits in with this is that the electrolytic process is stoichiometric according to the half reaction taking place in the cell, right? So like here we have a stoichiometry of 2 electrons for every 1 copper ion, which produces an atom of copper, right? So that is a stoichiometric relationship of 2 to 1. Now, something good to note that I have put up here is there is a unit called the amp or ampere, which has units of coulombs per second, which is going to be good to keep in mind because usually when we're dealing with electrolytic processes or electrolytic cells, right, we are going to have some amount of time that we are passing a current, which will have a value of some number of amperes through the cell to drive a chemical reaction. And of course, since we are talking about all these numbers, no video would be complete without a sample calculation. So we're going to answer this question. We're going to calculate the number of grams of aluminum that could be produced in 1 hour by the electrolysis of molten aluminum chloride with a current of 10 amps. So the first thing we're going to do is figure out the number of coulombs that this is generating, right? Because amps has units of coulombs per second, and we know how long we have been doing this for. So if you don't know, there are 3,600 seconds in 1 hour, and we have been using a current of 10 amps, or that's coulombs per second. So we get 3.6 times 10 to the 4th coulombs that have been passed during this time. Right, and to figure out how many moles of electrons that is making, right, because of course, right, the stoichiometric relationship of electrons and atoms, we're going to be interested in moles of electrons. We use Faraday's constant because if you remember back, I said explicitly that the 1 mole is a mole of electrons, so if we're interested in the number of moles of electrons moved here, we can multiply the coulombs times the inverse of Faraday's constant here, right? 1 mole of electrons over 96,485 coulombs. And we find out that 0.373 moles of electrons have been moved during this time with that amperage. So now that we have gotten to this point, here comes the stoichiometry, right? Because we can use a half reaction here, right? This reduction reaction that's taking place where we were reducing an aluminum ion to aluminum metal using 3 electrons for every 1 aluminum ion, right? So a mole ratio of 1 to 3. And we are going to set up a stoichiometry problem where we have our value that we know, right, our 0.373 moles of electrons. We have our mole ratio of 1 mole of aluminum to 3 moles of electrons. And then to convert from moles to grams, our good old atomic mass of 27 grams per 1 mole for aluminum. And in the end, we find that we have 3.36 grams of aluminum that is produced from this reaction in 1 hour with that particular current. And so that is it. This was a very short video, and that's it. We're done with electrochemistry. So I will see you in class, and we can talk about anything that we need to catch up on or anything that we have missed or skipped over in these videos. And so I will see you then.